Познавательные тексты на английском языке. Что происходит в атмосфере Солнца? What happens in the sun's atmosphere?
The sun is surrounded by an atmosphere composed of tenuous ionized gas. The solar atmosphere consists of several layers. The lowest layer is called the photosphere. It is a very thin layer. The photosphere is opaque to visible, optical light, so it obscures the sun's surface from us. That is, when looking at the sun, an external observer sees the photosphere enveloping it, not the sun's surface itself. Above the photosphere extend layers of the atmosphere that are transparent to observers, called the chromosphere and the solar corona. The solar corona is the largest layer. The solar corona can be seen during a total solar eclipse. It is a silvery glow that extends from the sun for several solar radii. The corona consists of extremely tenuous gas. Note that the radiation from the chromosphere and corona is more than 10,000 times weaker than that from the photosphere. Just like Earth's atmosphere, the sun's atmosphere is unstable. Various climatic processes occur in the sun's atmosphere, related to the movement of ionized gas, plasma, which makes up the atmosphere. All atmospheric phenomena on the sun are caused by magnetic fields emerging on the sun's surface and are called solar activity. On average, the sun's magnetic field is twice as strong as Earth's. Since the sun and its atmosphere consist of ionized gas, the gas ions, being electrically charged, are easily set in motion by the magnetic field. As a result, gas flows arise in the atmosphere above the sites of magnetic field rejections from the sun's interior. They are observed as various new formations in various atmospheric layers and are called active regions. In these areas, active directed gas movement occurs. These are areas of increased gas density, brightness, temperature, and magnetic field strength. Thus, active regions called spots and faculae form in the photosphere, spicules form in the chromosphere, and prominences form in the corona. A spot is a location in the photosphere from which gas is emitted. Spots usually form in groups. Spot groups can be several thousand kilometers in size. Spots are surrounded by dark regions called the penumbra and umbra. While the temperature in the spot itself is elevated, the temperature in its umbra and penumbra is slightly lower than in the rest of the photosphere. Spots have a very strong magnetic field. In spots and umbras, the field strength is several thousand times greater. Spots typically live for about a month. The largest spot can live for several months. A faculae is a network of bright chains that usually surround spots. The total area of the faculae chains is approximately 4 times larger than the area of the spot they surround. A facula lasts longer than the sunspot around which it forms, often for a full year. Faculae, though less bright, also occur independently of sunspots. The total area of faculae during years of solar minimum activity is small. During years of maximum activity, faculae can cover up to 10% of the solar surface. The magnetic field strength of faculae is increased by 5 to 300 times. Thus, the magnetic field of faculae is significantly weaker than that of sunspots. In the chromosphere above sunspots, the magnetic field strength is increased by a factor of 1,000, and above the penumbra and faculae, by a factor of 100. In the upper part of the chromosphere, gas forms clusters called knots. The knots combine to form large cells. They cover the entire disk and form a chromospheric network. In each network cell, gas spreads from the center to the periphery. The lifetime of a cell is several days. The magnetic field at the cell boundaries is strengthened. Above the sunspots, the ordered structure of the network is somewhat disrupted, forming a vortex-like structure similar to a cyclone. In the upper part of the chromosphere, against the background of the network formed by the knots, there are so-called spicules. Spicules are areas of increased brightness, corresponding to a twofold increase in gas density. Spicules have a columnar appearance and occupy 2% of the solar disk. The lifetime of a spicule is several minutes. The mechanism of spicule formation is related to the complex structure of magnetic fields in the photosphere. Prominences are characteristic formations in the solar corona. Prominences are relatively dense clouds. Prominences are significantly cooler than the corona itself, with a temperature of approximately 10,000 degrees. The shape of prominences can be quite bizarre. The trajectories of gas movement within prominences can be very complex. The formation of prominences and the movement of gas occur under the influence of forces from the Sun's magnetic field. The most common are so-called quiescent prominences. These prominences are generated by sunspots. They are observed in the sunspot zone after solar flares. Quiescent prominences consist of streams of gas flowing from the corona into the sunspot zone. However, prominences last significantly longer than sunspots, up to a year. Another type of prominence, fast prominences, is associated with upward ejections of material. Such ejections typically occur after solar flares. Thus, unlike quiescent prominences, fast prominences consist of streams of gas flowing into the corona. It is worth noting that the number of active regions in the solar atmosphere fluctuates cyclically with a period of approximately 11 years. During years of decreasing solar activity, fewer active regions are observed, while during years of increasing solar activity, more are observed. In addition to the long-lasting atmospheric formations discussed above, short-lived flares occur in the solar atmosphere. These occur during rapid reorganization of magnetic fields, which sometimes occurs during the development of an active region. In the flare region, complex movement of ionized gas and its glow occur due to the field reorganization. Flares occur in the upper part of the chromosphere or in the lower part of the corona, usually above sunspot regions. A flare is a sudden release of energy, resulting in short-lived electromagnetic radiation. The energy released during a flare is derived from the magnetic field energy of the active region. During a flare, various electromagnetic waves are emitted, ranging from X-rays to radio waves. Additionally, a sharp release of ionized gas into the interplanetary medium occurs. Several flares typically occur per day. During years of solar minimum activity, flares occur less frequently, while during years of maximum activity, they are more frequent. Large flares are a rare phenomenon. During large flares, X-ray fluxes near Earth are amplified tens of thousands of times, affecting radio wave propagation. The gas ejected during a flare upon reaching Earth causes auroras and magnetic storms.